everyone. Welcome back to Matafe Academy. My name is Nifon Ekmo. In today's section of the video, we will be discussing integration by part. And in our previous video, we've looked at integration proper, how to integrate a function, and integration by substitution. So why not check back on our previous video and learn how to integrate a function very well. But before we start, please subscribe to the channel page and click on your notification buttons for more videos. Now, integration by part is a method used in integrating a function that has two products, like what you've seen on the board now. We have 4x squared log 1x. This is a function of what? Two products. And we have a general formula we use in integration by what? Part. It states that the integral of u dv is always equal to your uv minus the integral of what? V du. Now, for you to know this formula is easy, but the issue is always how to pick your u and your what? Dv. Now, advise you to always pick a function that if you differentiate, the degree of that function will what? Reduce. And always pick that function as your what? U. So let's start solving this problem. If we have this 4x squared log what? X, I'll pick my u to be what? Log x. And my what? My dv to be what? 4x squared. Remember, in integration by part, the most important, what you're integrating is what? Your u and your what? Your dv. So now, if you have your u to be this and your dv to be this, you will find your du. And anytime you are differentiating a log function, you have 1 over what? X. And if you find your v, looking for v here means you are integrating this function. The differential of u is this. So for you to get your v, you have to integrate this function. So we are going to integrate this and we are going to integrate this. So if you integrate the v, you have your v. And if you integrate your 4x squared, you have 4x cubed all over what? 3. That's why I asked you to go back to our previous video and check how to differentiate a polynomial or a linear function. Having this all, we have to substitute all of them into the general formula. And the formula said that my integral of what? U. What is my u here? Log what? X. And what is my dv? 4x. So I can always write my 4x first so that I will not get you confused. Remember, my dv is what? 4x. And my u is what? Log x. And this is equal to uv. What is my u log x? What is my vd? So I'll write my v first. 4x cubed all over 3. And what is my u log x? Minus the integral. What is my v? 4x over 3 x cubed. And what is my du? 1 over x. 1 over what? X. I'm putting this dot because we are multiplying the two of them. Okay, so this will be equal to, now we are going to integrate this function. So we repeat this, and your 4x cubed all over 3 log x minus, now we want to integrate this function. This can cancel this and we have it what? Squared. So I repeat this so that you can see very well. Remember, this is a constant, so we can always break it out. And we have what? X squared. One of these has taken this, the x. But now this is what we are going to integrate. Now you have seen that from integration by part, we are able to reduce it to what? The lowest state, such that we can integrate without any issue. So that we have my 4x cubed all over 3 log x minus 4 over 3. Now if you integrate this function, you have what? Plus 1 all over what? 3. You have x cubed all over what? 3. Now we are going to multiply the denominator together. Alright, so from here, we're going to pick it out so that we have 4x cubed all over what? 3 log x minus, we pick this out, we multiply this, so we have 4x cubed all over what? 9 plus your constant of what? Integration. And that marks the final answer. Let's pick the second one and solve so that you understand very well. So this is where the first one starts. We want to integrate this function x cos 2x dx. Now remember what I told you there. For you to pick your u and your v is very important. If you pick the wrong u, you'll be suffering. So from here, if you notice that if I pick my u to be x, if I differentiate x, I have what? 1. So my u will be what? X. And my dv is what? Cos 2x. Now from here, I have to find my du, which is what? 1. If you differentiate a function of this nature, you have what? 1. And I want my v, so I'm going to integrate this. So that if I integrate my dv, I will have what? V. And if you integrate cos 2x, you have what? Sine 2x all over what? 2. Now, bringing out all these parameters, you have to remember the formula using integration by part. So we're going to solve all of them here. And I have then my integral of u dv. This is my u, and this is my dv cos what? 2x is equal to my uv. So that will be my x uv sine what? 2x all over 2 minus the integral of what? V du. What is my v? This. What is my du? 1. So 1 times this is the same thing. What is my du? This is my v. This is my du. So this times this will give me this. So I'm integrating this all over what? 2. Now, if you want to integrate this, you have what? Cos minus what? Minus cos 2x all over 2. So that will give us x sine 2x all over 2 minus. Want to integrate this function, so I'll have minus cos 2x all over 2 times these 2 now. I'm doing that for the sake of, I don't want to multiply through and we are writing 4. But some people will be asking, how did you get the 4? Remember we had 2 here already. And if you integrate sine 2x, you have minus cos 2x all over what? 2. So times all over these 2 that we had. So we are going to bring out everything. And I will have x sine 2x all over what? 2. Minus times minus will be now plus. And I have cos 2x all over what? 4 plus the constant of what? Integration. So this is our final answer. Look at this function. Again, I'm going to explain for the last time. We have two product function here, and as such, you are going to apply integration by part method. So I think wisely that if I use my u to be x, if I differentiate this, the degree of this will reduce, and that is why we are having it to be 1. And my dv to be this, 2 cos 2x. Now, for me to have my v from dv, you are integrating. So if you integrate dv, you have your v. If you integrate cos 2x, you have sine 2x all over 2. Having all these parameters, I substitute it into this general formula. A general formula used in integration by part. Wherever I see my u, I put what? X. Wherever I see my v, I put what? Sine 2x all over this. That's why we have this minus integral sine, which is this, sine 2x. Remember my v is sine 2x all over 2. And my u is what? X. And my du is what? 1. So 1 times this is what? This. And if you integrate this function, this is what you have. And I multiply this out, so this is what we have, plus the integral what? Constant. So this is where we are going to stop for today, but I will leave you to integrate this for me. Integrate x exponential what? 2x. And leave your answer in the comment box. So this is where we are going to stop for today. Please remember to subscribe to your channel page and leave your contribution and comments in the comment box.